In this video, we will walk you through how you can use the new Facade module in PROFIS Engineering. Start by selecting the new Facade module. In the Application tab, select the application type and the fastening technology. You can design with Hilti cast-in anchor channels, post-installed anchors, and industry-standard cast-in anchors. In this example, we will demonstrate a step-by-step calculation of an anchor channel on a facade bracket, subject to combinations of wind and earthquake loads. At the end of the video, it will be shown how easy it is to recalculate the solution with post-installed anchors. To start, navigate to the Plate tab. Define the geometry and dimensions of the plate. Start from left to right to change the dimensions of the bolt. The distance to the concrete edge can also be edited in the 3D view. Select Display Slotted Holes to view the holes in the plate. The software allows you to consider bolt bending in the slotted hole. Next, move to the Concrete tab. Cracked concrete is considered for this example. The concrete strength is set to 4,000 psi, and the slab thickness is set to 5 inches. The concrete dimensions could also be edited in 3D. Next, move to the Rebar tab. For this example, reinforcement greater than or equal to number 4 bar and stirrups can be selected. And in this case, it's reasonable to consider condition A for shear. Reinforcement in the concrete will help increase the resistance to edge breakouts. In this example, applied loads are combinations of self-weight, wind, and earthquake loads. Load factors should be considered. For instance, the earthquake's loads should include the factor omega naught. Copy the loads directly from the spreadsheet and paste them into PROFIS Engineering. It's important to check that the loads are being imported with the correct load axis, load direction, and units. Manually select each seismic load combination. The load combinations are now applied to the facade bracket. Move to the Load tabs to define load properties. Select one seismic load combination. In this case, select seismic tension and shear types D and C respectively, per ACI 318-19. In facades, it's common to adjust the final position of the plate. To account for the possible installation positions in this example, select the tolerance in X direction equal to the channel length. The tolerance in the slotted hole is set to 0.5 inch. We have now completed all the inputs required for this example. Next, move to the Product tab to find a Hilti solution. Start by selecting a product family. In this case, there is high load close to the edge, so Hack-Fee Edge is selected. This product contains reinforcement intended to enhance performance for high shear loads close to the edge. Select the type. Here, the available Hilti portfolio is displayed. The number 50 relates to the size of the channel. The T indicates that there are serrations in the channel lip. Seismic or other loads in the direction of the anchor channel require a serrated anchor channel. In this case, a bolt length is not sufficient, so it must be increased. A range of embedment depths are available. In this case, 4.173 is selected. A bolt that fits the anchor channel is automatically selected. One load combination is calculated. Select Calculate All Load Combinations to view all results. Update to the decisive load combination. This will display the load combination that corresponds to the overall highest utilization. The maximum utilization is 81%, and the design meets the criteria. The most unfavorable tolerance is determined, and the results displayed for this position. An overview of the different failure modes for the bolts, channel, concrete, and the anchor reinforcement can also be seen. Once satisfied with the results, print a report. On the first page of the report, the product and the item number are displayed, so it's easy to order. The controlling load combination is selected, and it's easy to follow the detailed calculations. The design with anchor channels is now complete. The same example can be solved with post-installed anchors. Go back to the Application tab and select Post-installed anchors. The calculations are now done for the selected post-installed anchors. A suggestion to meet design requirements with post-installed anchors is to increase the edge distance. If this can't be done, then a larger plate and more anchors would be necessary. This has been an example of how you can use the new Facade module in PROFIS Engineering. We hope you found this tutorial useful and that this module helps your daily work.